Hello friends, in this lecture we are going to learn about transfer functions. Here is the overview of the topics to be covered are objective, introduction, application, types of transfer function, challenges and its limitations, role of transfer function in volume rendering, components of transfer function, tools and libraries, and the recent advancements taking. The objective of this lecture is to cover all the topics related to transfer functions, their role, difference between 1D and 2D transfer function, to explore how transfer functions map data to color and opacity for volume rendering, recognizing the components and design methods, examine real-world application in fields like medical imaging and geosciences, to introduce tools used for applying and designing transfer functions in practice. Introduction to transfer functions. Transfer functions are the fundamental concept in computer graphics and visualization, enabling the mapping of raw data values such as intensity or scalar fields. So using the transfer functions, we can map various data values that are scalar into visual properties like color and opacity. Now, since we are drawing the image, so the color and the opacity are two very important factors that are keep to be in mind. This mapping is essential in volume rendering, where it allows the visualization of internal structures in 3D volumetric data without needing the surface extraction. Now, there are many fields where the internal structure of the object is to be known, but from the surface we cannot see the internal part and we cannot destroy the upper surface. So, in that field, the 3D volumetric with data rendering using the volume rendering is an important concept. By applying transfer functions, user can selectively highlight regions of interest, greatly enhancing the clarity and interpretability of the data sets. Now applications. So the major applications of transfer functions are in medical imaging for MRIs and CT scans, geology and fluid dynamics and climate simulation. Types of transfer function. Basically, they are divided into three major types: 1D, 2D and 3D. 1D transfer function map a single data attribute. It is simpler and efficient since only single data attribute is used. Limited expressiveness and common in medical visualization such as CT scans. 2D transfer functions, also known as multidimensional. They use multiple data attributes, enable better separation of structures, and are used for complex visual output such as MRI. 3D transfer functions. Now in the 3D transfer function, multiple data attributes are used. It enables better separation of overlapping structures, increased complexity. Since it is in the 3D format, so they are harder to design and fine tune compared to 1D where only single data attribute was used. Requires more memory and processing, and it is commonly used in advanced medical imaging, scientific simulations and fluid dynamics. Performance constraint. High resolution data sets can slow down real-time rendering, especially with complex transfer functions. Now, if they are the complex transfer functions, for designing them, we need heavy software which consumes much space and slows down the process timing. Ambiguity in visualization. Poorly chosen transfer functions can hide important structures or introduce visual artifacts. Now, it is very important to choose wisely the transfer functions, otherwise, the whole procedure will be devastated. Limited automation. Fully automatic transfer function generation is still an emerging research area and not always reliable. Now, since the automation is entering into all the fields, so in this field also automation is there, but it is limited. Fully AI based, it is not there. Role of transfer functions in volume rendering. Now, data mapping, visualization of 3D data, focus on regions of interest, improved clarity, and interactive exploration. This all can be done using the transfer functions in volume rendering. Now, scalar data such as density, intensity to visual properties like color and opacity can be mapped. Enhance the interpretation of a complex 3D data by controlling how different structures are rendered. Focus on regions of interest. Highlight specific features by adjusting opacity and color based on data ranges. Improved clarity helps distinguish between different materials or structures in volumetric data. Interactive exploration allows user to adjust visual properties in real time to explore different perspectives and highlight features. Components of a transfer function. Scalar values. It is the input data which we will give and then the processing will start. Visual properties such as color, opacity and structure. Since we are designing the diagrams, so it is necessary to describe the colors that are needed, the opacity and the texture. Lookup table, LUT, maps scalar values to visual properties. Transfer function curve defines mapping between scalar values and properties. Data ranges and thresholds set ranges for visual property mapping, and interactive controls allow real-time adjustment if any adjustment needs to be done there. So we can do it in the transfer. Now the tools and the libraries, their logos are on the next slide. First is the 3D slicer, the ParaView, and the ITK snap. So the ITK snap is used for medical imaging. We can create black and white and also colorful pictures which give us an easy understanding of the concept and the internal organs, since they are very complex and we cannot judge them or the cause through the naked eyes. So using this picture generation technique, we can have a brief understanding of the problem that is occurred. So it is very helpful. Recent advancements: machine learning for automatic transfer, function design. Now, machine learning and automation are a developing field which can be integrated in the transfer functions also. Smart visualization suggestions, that is also one of the AI based suggestion giver, and the real time GPU based rendering improvements. Now, this is a short quiz for you to take. What does a transfer function map? Name one application outside of medicine, and what are challenges in designing a good transfer function? Now, this is a very easy quiz which can be easily answered if you have listened to the lecture carefully. Conclusion. So, thank you so much for your support and watching this lecture up to the end. Hope you understood the concept of transfer functions, and if there are any doubts, you can write down them in the comment section. Thank you.